Okay, so what I want to do is prove the change of base formula, which is the formula that says if you have any log base anything of anything, it can be written as, say, the log base 10 of the thing you're taking the log of over the log base 10 of the base that you're using. Or you could pick any base besides 10 as long as you use the same thing. But let's just do the version with 10. I mean, you could do ln, those are the usual ones. But okay, this first, let's establish another thing that's true, which will be helpful for this, and that's that if you have, let's just use different letters instead of some arbitrary log. So you have log base b of y is equal to some value c. What I want to establish is that if you raise b to some power and you raise y to the same power, it's not going to do anything. It's still going to equal c, which is true. Like if you think of like log base 3 of 9 equaling 2, and you do log base 3 squared of 9 squared, well, it's still 2. 9 to the 81. Or let's think of another example, like 5. Log base 5 of 125 is 3. Well, what about log base 5 squared of 125 squared? Okay, it'll still work. So why don't we write this in exponential form? So b to the c equals y. And then the easiest thing, I think, is to just say, like, all right, let's just raise both sides to some arbitrary power. So say b to the c to the k equals y to the k, say. But we're interested in showing that if you raise b and y to the k, well, of course, exponent rules let us do that because b to the c to the k is the same as b to the ck. And b to the ck is the same as b to the k to the c. And that's the way we'd like to look at this, because now we can see exactly what we wanted to see. That if you raise k and y to the same power, sorry, if you raise b and y to the same power, k, c doesn't change in the whole relationship. C is still c. So it follows that log base b to the k of y to the k is still c. And b to the k to the c equaling y to the k, if you did that in exponential form, it would just be right there, which we derived from the first one. So, okay. That being said, let's get back to the matter of the change of base formula. Okay, so let's say you just have any arbitrary log, and just want to mess around with it and show, to say that it can equal the one we have, log of x over log of a, log base 10. Well, what you could do is a nice dividing by 1 in the form of log base a of a. So I can put this down. Use paint. There we go. So that's true, because all I did was divide by 1. But, okay, now since we know we can take the base and the inside of each of those logs to any power we want as long as it's the same power, well, why don't I raise a to something that would make it 10? Like, why don't I raise my base to something that would make it 10? Because that's what I want, is for it to be 10. So forgive me for not going straight vertical here, but let's just say we did that. So the log base a, well, what do you have to raise a to get 10? We have to raise it to the log base a of 10, because a to the log base a of 10 is 10. So log base a to the log base a of 10 of, and then by the rule that we just established, the x also has to get raised to the same power. So of x to the log base a of 10. Okay, so this is our base, and this is our inside of the log. And since we want a log base 10 in the denominator as well, why don't we do the same thing down there? So log base a to the log base a of 10. Okay, that's our base of, well, a to the log base a of 10. Inside. And this is going to allow us to get a lot closer to where we want to be, because all those bases, a to the log base a of 10, are now 10, which means we can just write that as just log. And then we also have the log rule that says exponents on the inside can be written as coefficients out in the front. So really what we're going to see, I can put this down a little bit. Oh, you have to go over here and do it. There we go. I'm use paint. Is, okay, it's going to be log base a of 10 out front as a coefficient, taking it out of the exponent. Okay, times the common log base 10 of x, just what's left without the exponent on the inside, over, take the a, okay, the exponent on a is log base a of 10, that can come out front. So it's log base a of 10 times log, because a to the log base a of 10 is just 10, so it's just a common log of a. Well, we can see now everything has worked out. Log base a of 10 over log base a of 10 cancels out, just 1. Oh, that is blue. I am so colorblind, oh my god. Cancel. And now we have the result that the formula tells us that you can change the log base a of x, an arbitrary log base whatever of whatever, into the common log of the whatever on the inside over the common log of whatever base you were using. And there really is no reason why you couldn't carry the same thing out with any desired base. All you would have to do is, in this step here, when you have a to the log base a of, make this number whatever you want. So if you did a to the, log base a of, we want to do 10, because it's like, well, I want to raise a to something that'll make it 10. I could have done it with e instead, and then you get the other situation, that the ln of x over ln of a situation. Because you'd see that, okay, well, the log base a raised to whatever you need to raise a to get e is just log base e, so some of these become ln's. This would be an ln, this would be an ln, and then the same thing would happen out front with the exponents coming out front, except they would both be log base a of e, and they would cancel each other out, and you'd still have x and a on the inside. So, yeah, that's a pretty easy way to get the result from the change of base formula that you want from, starting with just some arbitrary log. All right, thanks.